Welcome back to the Explainer Focus Learners. Today, we are taking a massive, and I mean massive, leap forward. We're going to level up our code by ditching those basic flat text files we've been saving user data into, and instead, we're diving headfirst into the world of dynamic, relational databases using PHP and PDO. If you've ever wondered where exactly your data goes when you click Submit on a modern web app, well, you are in the perfect place. Okay, let's dive into this. Here is our roadmap for today. We'll kick things off with why we even need databases in the first place, break down tables, rows, and columns, and then learn how to speak SQL. After that, we'll connect PHP using PDO, figure out how to display our data safely, and wrap it all up by building out the full data pipeline. Let's get to it. So, up until now, you might have been saving form submissions to a simple text file, something like submissions.txt. And sure, it's incredibly simple, but man, it comes with some severe limitations. Imagine trying to hunt down one specific user's email inside a text file with 10,000 lines. It's like finding a needle in a haystack. You can't search it easily, you can't sort it, and updating a record, you basically have to rewrite the entire file. The absolute game changer here is a MySQL database. It gives us structured rows and columns that are searchable, sortable, easily updatable, and literally built to scale to millions of records. This is where real-world data lives. And setting this up creates a perfectly balanced ecosystem. On the front end, you've got your HTML, the sleek forms and pages your users are actually interacting with. But that front end needs someone to talk to, right? That is exactly where our robust database backend comes in to catch the data, organize it, and store it safely. Our whole goal today is to make these two sides successfully communicate. All right, part one, tables, rows, and columns, the relational basics. If you can picture a giant, highly organized spreadsheet, you honestly already understand the core concept of a relational database. And the absolute foundation of this whole system is what we call the primary key, usually just named ID. Think of it as a unique digital fingerprint for every single record. It's a number that the database automatically increments every time a new entry drops in. Because of this primary key, no two form submissions can ever get mixed up, even if two people named John Smith submit your form at the exact same millisecond. A relational database table is just beautifully organized. You've got your columns across the top: ID, name, email, and message. And every single column has a specific data type. We use int for integers like our ID, varchar for shorter text like names and emails, and text for those longer user messages. Every time someone hits submit, a completely new row is dynamically added right into this structure. Which brings us to part two, speaking the SQL language, syntax and commands. Now, to successfully ask our database questions or give it new data, we have to speak its language. The good news? SQL is incredibly logical. There are just a few quick rules of the road we need to fire off. First, we write our keywords in uppercase, words like select, from, and where. Second, every statement finishes with a semicolon. When we're dealing with text strings, we wrap them in single quotes, but column and table names, leave those completely unquoted. Following these simple conventions makes your queries super easy to read at a glance. It's basically like writing a well-formatted sentence. The SQL sentence you are going to write the most is the select statement. Using select is exactly like asking the database a question. It doesn't change or damage your data, it just retrieves it. You can throw in a where clause to filter out exactly which rows you want back, and use order by to sort the results, like putting the newest submissions right at the top. Now, when we actually want to add data, insert into is the action that gets triggered the second a user hits that submit button. It takes their raw form data and transforms it into a brand new database row. One super important thing to note here, we explicitly leave out the ID column in this command. Why? Because remember, the database is auto-incrementing that for us perfectly every single time. Okay, let's pause for a quick pop quiz and a moment of dramatic tension. Besides select and insert, we have two other main commands: update and delete. So, what do you think happens if you run one of these commands, but you forget to include your where clause to target a specific row? Any guesses? Boom, you destroy the entire table. Seriously? That's the punchline, and it is incredibly high stakes. Forgetting that one little where clause is the literal difference between fixing a tiny typo on one user's profile and permanently wiping out every single piece of data your app has ever collected. So please, handle these commands with care. All right, part three,
connecting PHP with PDO. Let's build that bridge.
So we've got the database side down. Now, how does our PHP code actually talk to it? To build that bridge, we use PDO, which stands for PHP Data Objects. Think of PDO as the ultimate universal translator between PHP and your database. We use it over the older MySQL method because PDO is way more secure, highly flexible, and completely future-proof. In fact, you can use the exact same PDO code to talk to MySQL, PostgreSQL, or SQLite just by swapping out the connection string. It's awesome. To actually establish that connection, we use a data source name, or DSN, which defines our connection string. We wrap this whole process in a try-catch block. That way, if the connection ever fails, our app handles the error gracefully instead of just completely crashing on the user. And here is an absolutely crucial best practice. Always keep your database credentials safe in a separate configuration file. Never hardcode your usernames and passwords directly into your main scripts. Once we're finally connected, we have to make sure we interact safely. Enter prepared statements. You can think of a prepared statement like a giant security guard standing at the door of your database. First, you use prepare to send the basic structure of the query, using placeholders instead of the real data. Then you use execute to send the actual user values completely separately. Because it works this way, malicious user input is never pasted directly into an active query string. It is safe by design.
Moving on to part 4, displaying your data safely, fetching and viewing results. So what good is all this data if we can't pull it back out to look at it? When we run a select statement through PDO, we basically have 2 ways to extract that data. We can use fetch, which hands us just one row at a time. This is super memory efficient and perfect if you're looping through massive data sets. Or we can use fetchAll, which just grabs absolutely every row all at once and hands it back as an array. The one you choose just depends on how much data you're dealing with. Once you've got those rows, displaying them is a pattern you're probably pretty used to. You just loop over the rows and echo them right inside your HTML tags to build a nice visual table. But wait, notice how every single variable here is wrapped in a function called HTMLc_tags? This is non-negotiable. It ensures that if a user tried to be sneaky and typed malicious HTML or JavaScript into their form, it just renders as harmless text on your admin screen. It keeps everything impeccably clean.
And finally, part 5, the full data pipeline, bringing it all together.
All right, let's connect the dots and visualize the exact step-by-step journey of a single piece of data. Step 1, the user fills out the form and hits send. Step 2, your PHP script immediately jumps in and validates the input to make sure no fields are blank. Step 3, our PDO prepared statement safely runs an insert into command, dropping a pristine new row into MySQL. And step 4, the site admin loads up a private page which selects that exact data and safely displays it. It's a beautiful thing.
And this entire pipeline is exactly what you are going to be building. You'll wire up your HTML forms to a real database using PDO. You'll build out that secure admin page to display the records, and you'll really solidify your understanding of SQL syntax and connections. So, you've learned how to construct an incredibly powerful pipeline that takes user input and stores it permanently. You have built the bridge, but here's something to chew on. You've successfully built the database pipeline, but how do you lock it down from attackers? We briefly touched on security guards and cleaning our output, but the web is a wild place. How do you truly secure this whole system you just built? Well, that is exactly what we're going to unpack in our next explainer. Keep building, stay curious, and I'll see you then.